In this problem, we want to create a matrix that has this kind of structure. Starts at 24 and then counts down to 1. Now the first thing you should notice is that this looks a little bit like a program that we've covered before that we asked you about, which is in this program we want to create a matrix that does steps such that we get a countdown from 24 down to 1. Now this looks a little bit like a program that we've done before on the practice midterms, where we had numbers going from 1, 2, 3, 4, 5, 6, all the way up to 24. So let's start with that and then ask how do we modify the program that does something that we've done before to count down instead of up. So that program was something like this: clear, for I is equal to 1, and I'm going to use I to represent the rows, so I want 4 rows and 6 columns. So if I is my rows, I do 1 to 4, 4j is equal to 1 to 6, and then matrix I comma j is equal to something. Close that off, close that off. And we also used a counter variable. C is equal to 1, and then C is equal to C plus 1. And so this was the general process. We set a counter variable which counts the number of times we modify the matrix. We modify the matrix, and every time we modify it, we increment this counter. So every time this is done, every time we modify an element in the matrix, we also modify this. And so the number of modifications we make is computed by looking at the number of values in this, which is 4 total values, 1, 2, 3, 4, times the number of values in this list, which is 6. So I'll put a square brace here to indicate that it's a list or an array. So 4 times 6 is 24. We're going to make 24 changes to this. And in the first case, we have I is equal to 1, j is equal to 1, m of I comma j is equal to c. Then we have j is equal to 2, m of I comma j is equal to c. And again, it's important that after we do this, c is equal to c plus 1, we modify that value of c. And so what's happening here is you have m of 1, 1 is equal to the last value of c, which was 1. And c is equal to c plus 1, which is equal to 2. Only thing that's changed here is j and c. I is not changed, so I is still 1, j is 2, and is equal to the last value of c, which is 2. And then we want to modify c to be equal to c plus 1, which is equal to 2 plus 1 is 3. So this says first row, first column is 1, first row, second column is 2. And you've probably done this practice problem before, so I'm just going to execute this and look at what we get. Now we're counting up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so this is almost identical to a problem that you've seen previously, but now we want to count downwards. Well, how do we get this first value to be 24? Well, suppose I change c to be equal to 24. So now I have 24 over here, and then this will be 25. And now c is 25, and c is 24 plus 1, or 25 plus 1, which is equal to 26. So row 1, column 1 is 24, row 1, column 2 is 25. So it looks like it's counting upwards. which is not quite what we wanted. And the reason I got the same result was because I did not modify this. So this should be 24. Copy, clear, paste. So now we're counting up from 24. So this is correct, but then we're going in the wrong direction. So you look at this program and you ask, how can I change this so that this stays the same, but this value is 23? And the answer is, instead of incrementing the counter by +1, you increment the counter by -1, or you decrement it. So if I change this to be -1, now my counter variable is 23, and then at the next step, I'm plugging in m of I of j is equal to the last value of c defined, which was 23. And so now I have 23 here, and this is a minus. 23 minus 1 is 22. And so if I modify just this sign, I get this. 24, 23, 22, 21, and so on. And so this is the basic pattern that we covered before. You start with a problem that you know how to do, which was when this was starting at 0 or 1, and then we were counting upwards, and then look for the general pattern by expanding it out, and then ask how you modify it to get the numbers in the right place. How else could this be modified? Well, I guess I've asked you already one possible permutation of this question, which is I could ask you how to get this array starting at 24, ending at 47. And so the answer is here. That's one possible way to do it. I could ask you, how do I get all negative values here? Well, it would be this matrix, but instead of putting the value of c in there, I would just put -1 times c. So let's execute that. So I just get negative numbers. I could also ask you other questions such as, how would I get it so that, let's go back to the basic problem. How would I get this to work so that when I execute this, instead of getting 1, 2, 3, 4, 5, 6 going across, I get 1, 2, 3, 4 going down? So let's modify this to correspond to the program above. This is 1, this is plus, and this is 2, and this is 2, and then this is 2 plus 1, which is 3. So this makes row 1, column 1, 1, row 1, column 2 equal to 2, as shown here. But we want the second step to be modifying the second row, the first column. And so we want second row, first column. So we want these to be swapped. So you can ask, well, what happens if I do m of j comma I, m of j comma I? So this stays the same. And then now this is 2 comma 1, row 2 column 1 is 2. And so this looks like this is doing the right thing. And we can do one more step to verify that. J is equal to 3. This changes. And now the last value of c defined was 3. And then this is 3 plus 1 is equal to 4. So let's execute that and make sure we're getting the right pattern. And again, we wanted to have 1, 2, 3, 4, 5, 6, 7, 8. And that didn't work. And the reason is that I forgot to make the change up here. So it's m of j comma I. So this is the one that should give the correct answer. And again, you always check. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so it looks like it's counting in the right direction, but instead of having 4 rows, I have 6 rows. And we already know how to change that, is J represents the number of rows. So instead of having J go from 1 to 6, I can have it go from 1 to 4. And now I represents the columns, so I can go from 1 to 6. And this is the final answer. And again, you wouldn't know that you needed to go from 1 to 6 versus 1 to 4 unless you wrote out the steps. And here I wrote out only the steps for the first column. But as you probably note, when I do these examples without having the aid of MATLAB, I always write out what's going to happen at least for 2 steps, for 2 columns, or 2 rows. So here we have I is equal to 2. Everything else is the same. So I just got to modify wherever I see I. And so now I'm going to have I is equal to 2. I is equal to 2 here. I is equal to 2 here. And I need to work out what's going to happen for all of the steps to get the last value of C. So I have J is equal to 4. Here's J, so this becomes 4. Last value of C defined was 4. And then 4 plus 1 is 5. And so these are all of the steps for J is equal to 1 to 4. I've done all of the steps here. And then now the last value of I and J were 1 and 2. So this is 1 comma 2. Row 1 column 2 is equal to the last value of C is 5. And then we have 5 plus 1, which is 6. And this is 2 comma 2. And that is equal to 6. C is equal to 6, so this is 6 plus 1 is equal to 7. So row 1 column 2 is 5, row 1 column 2 is 5, and row 2 column 2 is 6, as shown here. Sergeant, hey, wake up.